Okay, welcome everyone. Thank you so much for joining us online and in person here in San Francisco. If you want to come start taking your seats, we'll get started. We'll just get started in a minute. We've got a great evening for you tonight. We've got talks and technical presentations and a panel discussion with leaders from Harvey, Cognition, Perplexity, and Fin, all on the theme of building great frontier AI products. I'm Jordan Neal, SVP of Engineering from Intercom. I'm going to be your MC tonight. But to get us started, I'm going to intro co-founder of Intercom, Des Traynor.
Thank you, Jordan, and good evening to everyone. Welcome to all of you here in SF and to the thousands on the live stream as well. I'm Des, co-founder of Intercom. We're the company behind Fin. I'm guessing you got it out, or I'm hoping you've got it up by now. We've a really fun evening ahead. We've got pretty much the entire leadership team of Intercom, CEO, CPO, CT, all the Cs basically are here along with me. We wanted to gather a group of great companies and great people to talk about frontier AI products. What we want to talk about is like what it means to be working on the actual edge, like really pushing things forward. This wave of AI that we're in is still kind of quite young, and it's very fast moving. Companies are blowing up in like the good way and blowing up in the bad way too. For us, we're betting really hard on AI. It's basically the future of our entire business. Fin, at its pretty young age, already has about over 6,000 like paying happy customers. It resolves over 1 million conversations a week. By all the data we have, it's the highest performing agent that's out there, and it's also the fastest growing thing that any of us in the company have ever worked on, ever, by a massive margin. So yeah, we're all locked in on AI, we're all locked in on Fin. When we look at the leading AI companies, of which we'd humbly submit Fin into, what we see is there's like innovation at all of the levels, right? In software, so many of us are so used to this world where like if you're working on something, it shows up in the product as UI that you can look at and point at and click and play with. We're far less used to talking about these like subterranean improvements, these ways in which the product gets a lot better, but you don't see anything change. What happens is the users realize after one update or whatever, shit, this thing's working really well now. And those improvements tend to be slightly more invisible because they're happening at the AI layer or any of the layers beneath. That's where so much of the magic of products like Fin, Harvey, Devon, Perplexity, that's where it happens. It's at this AI layer, through optimizations, through re-architectures, or even deeper again, at the actual model layer itself. That's where groups like our AI group, of which there's about, we've about 50 strong, there's a lot of the folks here who are out doing the poster sessions, are part of it as well. That's where they spend their time, right down at all the levels, finding all of the edges, all of the ways to make a truly great AI product. So as I said, we wanted to pull together a great group of people, a great group of companies, and a crowd to basically talk about what it means to go further, to go harder, and to go deeper when you're building AI, to really push the envelope. That's what tonight's about. And to kick us off with an opening keynote, I'm really excited to hand over to our Chief AI Officer, Mr. Fergal Reid. Thank you.
Thanks very much, Des, and thank you so much, everybody, for coming here today. So my name is Fergal. Des said I kind of head up AI at Intercom, and I'm here to talk about creating value at the AI layer and kind of share how we think about this important topic. Because, AI product strategy is hard, right? It's a very dynamic space. The rules change all the time. You think you're building something that's really valuable, and then something changes at a layer below you, and suddenly you have to revisit all your assumptions. And so, you don't want to spend time building things that aren't valuable. And so, we really think about this idea that, like, hey, there's an AI layer. And you're probably familiar with the idea of, very commonly, there's an application layer, right? There's the UI and the UX of the product people use. And, of course, there's the model layer, the LLMs deep down underneath that tend to power things. But really, there's a lot to do at the AI layer that we spend a lot of time on, too. Prompts, orchestration, logic, context. And we really think it's interesting to sort of look at different products and kind of taxonomize them using this lens. And, back when ChatGPT first came out 2 years ago, there was a lot of talk about, like, tin wrappers. And really, the first ChatGPT experience itself was kind of a tin wrapper, but which I would say, like, the application layer is pretty thin. There's an AI layer, but it's also thin. Really, you're very nakedly talking to the model when you play with that kind of ChatGPT version 1. And of course, this has changed over time. I think now, another way of taxonomizing things, or another set of products, is sort of the AI-enabled application, right? And a good example of that might be, the early version of Copilot in VS Code, for example, right? Big application that people have been building for decades, but then with like a pretty thin AI integration and, with a very small AI layer above the model there. And I think, as time has passed, 2 years in, you're starting to see more and more things that are what maybe we might call an AI native application, right? Where there's an application layer, and maybe it's a little bit relatively smaller, and there's a big AI layer. There's a lot of engineering around the models. And, Fin, our product today, would probably fall into this category. There's a very complex kind of RAG layer above the models that I'll talk about in a minute. And as AI kind of has matured, I think we're seeing more and more products that look a little bit like this. And that's great, right? If you're building a product, this is a very nice, clean narrative to be able to tell. But I think something interesting happened recently with Claude Code, which some of you may have seen. In case anyone hasn't seen Claude Code, it's sort of a very kind of command line terminal-based kind of application that people use to write code. And it was just quite interesting because it was really the model layer kind of striking back, right? It really looks like, a relatively thin application and a relatively thin AI layer, and the model doing a lot. It looks a lot like the tin wrappers of 2 years ago. And this is kind of interesting. And, Claude Code has a sweet spot. It doesn't do everything. But it's influential. Suddenly it spawned many clones, and it's quite quick to clone because it's relatively thin at the layers above the model. And I often think, like, what does someone like, JetBrains, who make IDEs for, like, decades, think when they see something like this, right? A part of their application surface has suddenly been, very quickly commoditized and very quickly made thin by something like this. I think it's very dangerous for application companies to look at this sort of trend if this goes. And so obviously, we have a thesis here, right? We think that, there's generally a lot of work to do above the model there. But we kind of think that AI companies, they can't ignore the risk of the model layer sort of coming up quite suddenly and, making some of their investment suddenly outdated. So really, we think that anyone building deep AI applications, you have to have a plan to build durable value around the models and at the AI layer. And we'll argue today that it's possible to do this and share a little bit about what we're investing in and why we think this is something that companies like us can deliver on. But first, I want to share a little bit about our context and our history, because it's kind of important for the direction we're going. So Intercom, we make a customer support platform in Inbox where humans go and answer customer support questions. And back in 2018, we started to build this product we called Resolution Bot, which was like a previous generation, I guess, AI chatbot. Humans would have to go and settle up and configure intents and then define like how it would answer a question. We did a lot of work to make this as seamless as possible. Back then our tech stack was very, BM25 meets Word2Vec. This is like a slide from way back when. It's like a hand-engineered sort of, information retrieval Word2Vec thing that I actually wrote. And, this used to be previous generation. 2019, we're an early adopter of AI, and I went and did some splunking through our GitHub for this. And I think there's one thing I want to highlight here is, we were putting neural networks in production. We put Muse in production pretty soon after it came out, and we really ended up building sort of a proto vector DB with cosine similarity and everything back then to kind of power our previous generation bots. So we're kind of in this space, and we were well equipped when the world changed with ChatGPT. to start building Fin. So I'll quickly touch on the story of Fin. So we've kind of been watching this space for a while. This is an internal memo I wrote about Google Lambda, which a lot of us had seen at the time, and was sort of, I guess, a precursor to ChatGPT. And we're kind of like looking at this and watching, and then suddenly ChatGPT came out, and we moved very fast on it. And we built Fin, which we considered sort of a breakthrough AI agent. We launched Fin on powered by GPT-4 on GPT-4 launch day. It was RAG from the start, and we had already started investing in RAG, I guess, from maybe January 2023. One of the first production RAG systems in customer experience, and maybe ever, I'm not sure. I didn't know it was called RAG at the time. And really what we invested in 23 to 24, we invested a ton in prompt engineering, right? I think like a lot of people at the time, you had to do a lot of work with the models of 2023 in order to get good results out of them. You had to do a lot of prompt engineering. We invested a ton in our RAG pipeline, in sort of like, trying out different types of retrieval strategies, different types of chunking, things like that. And then we did a whole lot of testing and optimization. And over time, through experimentation and gradual refinement, we ended up with an architecture that looked a little bit like this. This is kind of the Fin architecture from a few months ago. I'm not going to talk you through it all, don't worry. but it's just to show that this is where we got to optimizing A/B testing bit by bit, to build quite a complex industrial strength product with a whole lot of different pieces. We were summarizing issues, doing custom retrieval, et cetera, et cetera. And really, at that point, in that sort of 2023, 2024 timeline, what we really were investing in was this experimental culture. Always A/B test everything in production. And it was always deeply unintuitive, whether a new thing we were trying was actually going to improve the product or degrade it. And so we all had to A/B test everything. And of course, we built a bunch of product features around core Fin, kind of helping the rest of the Intercom org to do that. And there's a lot of pain and suffering there, as we had a big SaaS company, and we were sort of learning how to build AI with probabilistic systems. And Molly is going to give a little bit of talk of pitfalls there. But overall, we're proud of where we got to. It worked out pretty well. And this is probably the chart that I am most proud of in my time at Intercom building Fin, which is the chart of Fin's resolution rate over time. And very weirdly, it kind of grows almost in a Moore's Law style way. Each month we're we've got a bunch of things we can try, and probably it won't work. Probably we're asymptoting out in terms of the quality. But each month we get about, on average, a percentage point of kind of end-user defined resolution improvements. And it's working pretty well. We've got about $50 million of ARR at the moment just from Fin, and on a good trajectory, if it holds, to $100 million in a couple of quarters. So, Fin today, as I was saying, it really has a sort of a mature AI layer powering it, right? There's the models, but then there's a ton of stuff around the models. But how do we take that to the next level? And this is really what I'd like to talk about today, which is what we've been doing over the last sort of 6 months. And again, we're wary about the model there coming up. We really want to spend our time building durable differentiation. It's easier today to build something competitive with Fin than it was a year ago, and certainly than it was 2 years ago. So what do we do? How do we take it to the next level? One thing we spend a lot of time thinking about is this quote from Alan Kay, right? People who are serious about software should make their own hardware. It's quite an influential quote on Apple. It's quite a cool quote. How does this apply to the AI era, right? And we spend a lot of time thinking about this. And I think, as Des said earlier, we really have an emerging thesis that you've kind of got to go quite deep into the AI layer to build the best products. And so I'm going to talk about the results of our deep investment here. And again, we still do, of course, use LLMs from Frontier Labs. Anthropic for Fin Core is an excellent model, OpenAI partner for voice. But I'd like to tell you about some of the work we'll be doing ourselves, because we think this is, we speculate, we don't know, right? We don't have a crystal ball. But we think this is a template for what a lot of AI applications will do over time. So I'm going to talk at a high level about some of the things we've been doing recently. If you want to get more technical details, we're releasing a whole lot of blog posts today where we're really sharing a lot of technical information about the work we've been doing over the last 6 months. And of course, we've got poster presentations here too. So one of the first things we've set out to do is to build a custom re-ranker. I'm going to share a little bit about our journey doing that. So what's a re-ranker? Fin, as a RAG application, goes and tries to answer a question using a whole bunch of chunked knowledge, typically from your help center or your other sources of documents. And we've discovered over time that the performance of an LLM in actually answering a question is super sensitive to the exact set of documents that we retrieve, and even, weirdly, the order in which we retrieve them and present them. And so building a re-ranker can be really impactful on the performance of the system overall. And so, we've ended up building our own custom re-ranker over the last 6 months using modern BERT as a building block and training it on a whole bunch of data from Fin. And I guess one thing we're sharing that is, somewhat surprised us is that for our use case, our own re-ranker here has outperformed the previous best-in-class re-ranker we were using, which is Cohere re-rank 3.5, and improved answer quality, and it reduced our costs by a lot. And this is going to be a consistent theme this evening. I'm going to talk a lot about how moving to custom models has improved performance, but also decreased cost a lot and increased efficiency, decreased latency. We sort of think that this is an emerging pattern that probably a lot of people are going to do. Some backtest results here. Really quite surprisingly large gains from moving to our own model trained on our own data. We've also built a custom retrieval model over the last while. We call it Fin.CX Retriever. Again, this was initially trained on 300,000 real user queries, each of which had a hard resolution. A hard resolution is when someone affirmatively says, yes, thank you, Fin, this has positively answered my question. And our ability to have a high-performing AI application, we think gives us an advantage that's proving out when it comes to training our own models here. And our retriever model, which was a fine-tune of a Snowflake model that had a pretty good performance cost envelope, has performed very well, has outperformed the previous competitive retrieval models that we were using. And I highlight this because I think there's something interesting here in this sort of second box, which is that we compared here, we did an experiment where we said, like, hey, how good is the retrieval model for the applications it's trained on versus how good is it cross-application? What's it learning in terms of learning to be a retrieval model for customer experience generally? And obviously within application it's the best, but it also does generalize pretty well out of sample across apps, which was better than we expected. I guess the theme here is that there's still a lot of room for optimizing and for improving by training on very broad, application-specific data. We've also built a custom issue summary model that powers a part of Fin called Fin.CX Summary. I think this is a good example of the emerging hypothesis of the small LM hypothesis, essentially, that small language models can sometimes perform pretty well when trained for a specific task. NVIDIA wrote a paper about it recently that's been quite influential. So, within Fin, one thing we've always done is we have summarized the end user's query before going to do the RAG thing, because sometimes end users ask very strange things. They can have a lot of noise and a lot of weirdness before they actually ask a question. And exposing that raw to your RAG system, it has not been as performant for us as first canonicalizing that query. And so we've always had an issue summary layer, and this has been our attempt to kind of build our own model. We had an LLM, typically used GPT 4.1 for that as a kind of a fast performant model, but we want to experiment with improving it. And one thing that's always been tricky about issue summary is if you say to an LLM, hey, summarize this issue, and there's no issue there, they often will get confused. And so we've always built we've always had a few-shot approach to solving this problem, where we kind of say, hey, if there's just a greeting, or if it's just a goodbye, or if it's just a negative reaction, please don't summarize the issue. We've kind of always prompted the LLM in a few-shot way to improve its performance. But I think as anyone who's run a production LLM at scale for a while, this runs into a problem. Every kind of battle-tested LLM, you few-shot in this way, you end up with many, many few-shot examples. And you get your latency goes up and your performance goes down. And so this is an area we experimented with, kind of a custom approach. And our sort of key insight to this problem was to split the task. To first say, train a classifier that was doing a good job at figuring out if there actually was an issue there or not. And then if that classifier said, yeah, there is still an issue here, then to kind of use a small LM to then summarize the issue. And so, this is kind of a schematic of the classifier piece. Again, modern BERT's been a great building block here, trained on data from our experience. And then we have LoRa fine-tuned Quen3 14B, which was good enough to equal in our evaluations GPT 4.1 for this summarization task. And then we got like a more performant model, but kind of more importantly, only slight increase in resolutions here, cost reduction, but more importantly, improve the quality of our product. Moving something, you don't do it lightly, but moving something from the LLM to a proprietary system that you control does enable you to get more fine-grained control and more fine-grained tuning of it. I've got 2 more to go, and then I'm going to tie this into an overall narrative and then take questions. We built a custom escalation detection model for Fin as well. Escalation, when somebody is getting fed up with Fin and they want to talk to a human, it's just not helping them. It's very important to delivering a high-quality end-user experience. But it's a difficult thing to build a machine learning model for, because our different customers provide guidance in the form of free text input that kind of defines a policy for when Fin should escalate and when it shouldn't. And we really, we have sometimes, based on the guidance will be like, definitely escalate if this happens. Sometimes it'll be like, definitely let Fin answer. And then sometimes there's a gray area in between. And so we spent a while working on this. We tried, a Gemma fine-tune. We tried Quen models of different sizes. And that was good, but we were kind of keeping the push to see if we could find a smaller, better model. We actually ended up training sort of, again, a custom model using encoder backbone model using modern BERT as a building block, with a multi-class classification on top of it, multiple different classification heads. And this worked out really well for us in the end. We got a resolution rate increase, latency decreased by about ½ a second, cost per resolution decreased by 3%, and we got finer grain control. And it's like, each one of these models is incremental. It's like 3% here, 5% there, but it all adds up. When you do it at scale, you start to end up with an application that starts to look a bit differentiated. And the last thing I have to talk about today is we've also built a feedback model, right? Sometimes feedback is tough, right? If you want to have a product like Fin and it's dealing with real users, it's not easy to extract feedback from that. So, an example here that kind of build that intuition is someone might say, Fin might say, oh yeah, to cancel your subscription, you need to do X, Y, and Z. Was that helpful? And the kind of thing real people say back is like, yes, but apparently my email is also wrong. What should I do next? And this is a really hard challenge for a machine learning system. It's getting easier, but traditionally it's hard. We ended up building sort of a multitask architecture to do that, where we had like 3 different classification heads. One was for like feedback. Is there no feedback? Is it positive? Is it negative? Another one, has the user got a follow-on question? And a third classification head was, have they ended the conversation or not, with sort of a shared modern BERT layer. And this worked really well for us. We once again got like a smaller, more efficient model with really high overall accuracy. With several other kind of initiatives in flight like this. So that's sort of a whistle-stop tour of some of our investments. But I guess, like, why am I sharing this? There's a thesis here that I want to kind of to deliver. In our experience now, you can get really good performance by replacing LLM calls with more special purpose models. We still use Anthropic for our hardest LLM task of like actually synthesizing an answer to a question from the RAG content. But all the other pieces of Fin, like, they all work together to add up to a good product experience. We've been able to improve our business metrics, improve our resolution rate, improve our margin substantially, and then also get much more fine-grained control in terms of like the quality product, the quality trade-offs and metrics. That's one takeaway. We're pretty happy with how this has worked out. Data from a high-performing frontier application has turned out to be a very valuable building block for us, more so than we anticipated, right? And I guess that's one thing we're sharing is like, hey, our production data turned out to make a relatively small investment to get really massive returns. Like, it really surprised us that our model turned out, a re-ranker in particular, that was better than Cohere. And Cohere is still a great model, but certainly for Fin and even cross-customer, even out of sample on a customer basis, it worked really well. So we kind of think that there's an emerging pattern here that we would suggest to anyone with a deep AI product. Start out, build your product expensively, get the quality really great, stabilize the product, and then go and optimize it. And there's a lot of room for optimizing over time. And this is how we believe in trying to add sustainable value at the AI layer. And that's really what we're doing. And we're sharing a lot of this information for the first time today because in the past we've a habit of building really good technology and not talking about it much. And we're trying to change that and talk about it a lot. And so we have just published a series of blogs. If you want to get into a lot of technical detail on each one of these things I've talked about, are available at Fin.ai research. And obviously we have technical presentations here. We're really thankful to such a great audience for coming out, and I would love to answer any of your questions briefly. Thank you. I think we have roving mics if anyone wants to put up their hand and ask a question. Sir, in the front.
Thanks for the talk. You mentioned using log data for training re-rankers and retrieval models. Can you talk a bit more about your experiments with LLMs as teacher models? Because for things like relevance, I assume they're still very powerful, and you can distill down to modern BERT.
Yeah, I think LLMs as teacher models can work. Obviously, you have to pay close attention to the terms of service of the LLM that you're using. There are open LLMs that are very powerful these days, and they can work very well as teacher models. And definitely there are. We think there's a lot to be done there. We think that there's an awful lot of things that people are using in production where they have a big, heavy LLM, and that can be a great way to get started. But that, it's been surprising to us how well the modern BERT-style encoder-decoder models can work with a teacher model, perhaps a large open-weight teacher model. So yeah, I think that's a great direction. I'm very bullish in that direction of investment. Yeah. Maybe one or two more. If you have a mic for this lady here.
Hi, thank you for taking my question. Great presentation.
Thank you.
I was curious, how are you attributing acquisition of new customers to the advancements that you've made to Fin? Meaning, have you gotten customer feedback that the new improvements have led to expansion? It could also be just a coincidence. I was just curious.
Sure, no, absolutely. So, we compete a lot on the quality of our product, and we build based on a successful resolution. So we were a very early adopter of outcome-based pricing. We bill $1 when Fin successfully answers a question. And so there is a sense in which improvements in the core product directly add to revenue for us. But also, we find that customers, especially sophisticated customers, they run Fin in head-to-head trials against other competing products. And we really encourage that. And the gold standard is an A/B test. Sometimes people do before or after tests, and sometimes they do an A/B test. And so we really feel that that's our differentiator, and that's something we compete very hard on. And that's really the reason why we do this. And that's kind of the single biggest thing that we have deeply, deeply invested in from a technology perspective. And it does work for us. It does help us win head-to-heads and convince customers to come to Fin. We're very proud of that. So, yeah. And maybe last question here, if that's OK. This lady here in the pale shirt.
Sweet, thanks. Understand the value of data as like a core asset to build differentiation, but how do you think about integrations and context when most users outside of like core B2B likely have as a horizontal LLM up on their window as like a split screen? And how do you build like that like platform OS?
Right. So, I mean, that is a hard question. So, you know, integrations and context. Obviously, there's a lot going on. Space is moving really fast. MCP is a huge, big change to the space to help people pull in context from lots of different you know, platforms. We have a procedures, a tasks product. We spend a lot of time helping people integrate Fin when they use it with their other systems, and you know, calling APIs and like being able to kind of handle complex queries like that. But look, I think your question is even broader than that. It's a very evolving field. There's a lot of different players, and there's a lot of people trying to solve this problem of like, I have an AI system, but to make it really valuable, I need to integrate it with all these other business systems. And there's a lot of hard slog there. There's a lot of hard work to do that. We have like teams that will partner with a customer and try and help them do that integration. But it's a lot of legwork. It's still hard to do. MCP is really changing it. Yeah. Is it a driver of differentiation for us? It's definitely something we're good at and we invest heavily in. I think everybody is running around trying to connect the AI systems to the other systems of business. So I think it's a valuable thing, and if you connect it to an application that does a great job, it'll do a good job. I'm not sure if it's a differentiator or not. Okay, I better go at that. I want to hand you over to Brett Chen, who has very kindly agreed to come and talk to us today. A tech lead, a member of technical staff for Perplexity. He's going to give a keynote on scaling intelligence. And Brett has done some great work in the past, including writing a book on lifelong machine learning. And a great chat with him before this. Thank you so much, Brett.
Okay. Hello, everyone. I'm Brett. Today I'm going to share our first-hand experience of building AI agents and models to serve millions of users and hundreds of millions of queries at Perplexity. And I want to pass on some lessons and takeaways I've learned in the past and help you prevent the similar pitfalls. So yeah, high level, I suppose some people probably heard about Perplexity and maybe use Perplexity, but for those who haven't, I'll talk about a little bit about Perplexity as a company, and then I'll showcase some of our recent agentic products, and then I'll go into the AI agents, and then wrap up talking about some of the post-training models. So Perplexity, it started 3 years ago. Actually, last month, we just had the 3 years anniversary. Right now, it's valued at 18 billion. We have about 300 employees globally, and we have office headquartered here in San Francisco, just like 3 blocks away, and Palo Alto, New York City, Austin, and some other places. So this is our data 3 months ago, public data. And our recent data has been even stronger. But let's talk about the data in May. We have 780 million queries. And then it's 20% monthly growth. And we have 22 million active users. And ARR is 100 million. And more recently, our app has been ranked as the #3 in the US App Store for productivity. And our end of year query target goal is 1 billion queries per week. And the reason I said that the data has been even stronger recently because our recently launched browser called Comet. So this is AI native browser that can actually help you do a lot of things, like summarize, research, automate stuff. It can have the single interaction with US user and do a lot of complex stuff, right? Like book meetings, like compare products across different tabs, and research topics without you switching back and forth between different apps. And it has your context, it has your section, and then it can adapt to your workflow and preferences. And it also stores data locally and keep your data private and secure. And another very interesting one is we have the voice integration, and we really believe that's the future in interaction of browser. Because nowadays, we mostly use the keyboard and mouse, because that's just how we click on a website or type stuff, right? But with AI assistant, like that, we don't actually need to type to AI assistant. We can just talk to it, just like you talk to another person. So so let's watch a quick video about Comet.
pull up the clip of Jensen demoing Perplexity Labs.
I've pulled up a YouTube video showing Jensen demoing Perplexity Labs at GTC Paris. It should be at that moment
to formulate what is now agentic AI. Let's take a look at one example. Let me show you something. It's built on Perplexity.
Yeah, by the way, something I'm always amazed, our marketing team is great at building videos. Okay, so another product, also a recent one, agentic product is called Deep Research and Labs. And it's focusing on those long-running tasks that would take human beings hours, if not days, and we can finish them for you in minutes. It can deliver in-depth and cited analysis report and aggregate different web sources, documents, and remove duplicates, as well as resolve conflict. And it will summarize that and then present for you to make the best decisions. And then it also can produce the report in different formats so that you can easily share with others. So for example, you can, we have the output that we can build some dashboard or mini apps that you can use yourself. You can create a slice, and then you can also export them to different format of documents, and again, iterate them. Some other products include like different verticals, like Perplexity Finance, where you can look into the stock market and economic data and really tailor that to the market or the events that you care about. Similarly, for the sports, like you can go and search particular leagues, teams, and players. And then we also have like our Discover product, which is a feeder system that curate and provide articles that tailor to your interests and your needs. And there are many, many other products. The point that the reason I want to bring up this product is that I want to give you a sense of Perplexity scale, like the number of different products that we're building, and that connects to the next point of AI agent, because it poses a unique challenge to AI agent that we want to build these centralized AI agents that actually work for all these products and meet all these products' needs. So okay, let's go into the meat and potatoes of this talk, AI agents. So I'm going to first chat about the production level AI agents, like what that means, right? Like what kind of considerations we have there. And then I'm going to talk about the prompt, I'm going to talk about the eval, personalization, and then the MCP. Okay, so like this is just as Fergal mentioned earlier, like right, like in the early days of LLM, like it's just simple application talking to LLM, right? Like single step iterations, like things really simple. And then we have AI agents, which is the layer between apps and models. And the AI agents are like sort of foundation of this layer, right? Doing the orchestration, all kind of workflow. And at Perplexity, we are not just talking about AI agents, again, not just communication between one model and one application. Actually, we have access to dozens of models from different providers. And then we use those models, build this AI agent, and empower many more products and applications. So here we're both talking about external models as well as we have our in-house models. So that's the kind of component I'm going to talk about, and that's where I lead my team, building these AI agent architecture and workflow to work for different cases. So yeah, so let me first of all talk about like what is like an AI agent, right? What kind of problem it is. So just to abstract a little bit, like instead of talking about certain components, certain details, I want to talk about like want to frame it as it's a multi-dimensional optimization problem. And the different dimension, different objective and constraint here. The first one is quality. And that's what people talk about all the time, right? Especially when the new model comes out, right? It's like, I'm best at doing this task, I'm doing that, like my score is X% higher than the other ones. And obviously, there are many ways to evaluate it when it comes to like accuracy, when it comes to relevance, coherence, hallucination. So this is something I think most people are familiar with. The second one is latency. And this is something I think, again, many of you care about, like we want the model to be fast, so we don't want a user to wait forever, right? And actually, interestingly, when I talk with people within the company as well as outside company, these are only usually two dimensions they think about, and that's it, right? They just say, oh, I want a high-quality model, and I want a model to be fast. And I was like, do you have other considerations? They say, no. OK. But actually, when it comes to the production-grade AI agents, there are other key factors. So the third one here is actually reliability and availability. So this is actually the key difference, in my opinion, that will distinguish your product from others. Like, from my experience, it's very easy to build a demo or something that can achieve I would say 50, 60% of success rate. But it's much harder to get to 90%, 95%, or even 99%, right? And that's where you go from an average product to a great product, and that's reliability. So if there's just one message you can take away from this talk, is reliability is what distinguishes your product. And the reliability here, again, when it comes to like the error rate, the success rate, the like uptime, and all kind of things. And when it comes to the different models, it's even challenging because then we need to balance, do all kind of load balancing. The last one, and obviously it's still also top of mind, is the cost, right? We want the best model, we want like best quality, but still they come with a cost. So there is a balance here. And so for each product, we need to care about these. And there are obviously other things as well, like security, all kind of other things. But these are usually the top four that we think about. And at Perplexity, we also need to think about these across different applications, because it's not just one product. Like we cannot just feed one model for all products, right? We need to load balance. We need to figure out what models works best for the product. OK, so let me go into some of the touch base on some specific points. Just want to, again, share our experience, and I hope you can learn something and then avoid the pitfalls. So I'm going to start with prompt engineering. And you may think, hey, Brad, like it's 2025, right? Why are you still talking about prompting, right? It's something that happened early days, at the beginning of LM. But in fact, believe it or not, like even at Perplexity, as we're doing AI from the very beginning, prompting is something that we still spend a lot of time and actually require us to refactor and redesign our system all the time. It's because this is also a field that is moving fast. So when it comes to prompting, again, conceptually it's very simple. Like there are just some messages there, like usually different three types: system, user, and system, right? Like you put the information into one of the type and put them together, make an animal call. Okay, but when it actually again comes to the production level, there are a lot of considerations. Like for example, single prompt versus multiple prompts. What does it mean? Like in the previously, like we had this mindset like, oh, we had a new product, let's create a prompt. We have another model, let's create a prompt, right? Why not? Like, but then we got an exponential number of prompts, and then no one can manage it. Like, let's say I want to update one prompt. I don't know if I need to update others. And then these prompts all look very different from each other. So then we started doing all the refactoring, like we make sure we have modules. We make sure we share different templates, right? Like people just cannot just create random prompts for their products. Like we have some guidance there. And then there are interesting questions about, okay, who actually owns the prompt, right? When it comes to different teams. Should it be the product team who actually know the product better? Or should it be the AI team who actually know the prompting better, but may not know the products as well as product teams? So again, it's a balance. It's some sort of middle ground. But again, that's something that when it comes to different teams of product, it's very tricky to figure out. Another thing, context engineering. I think some people asked about context before. Like, some people say context is everything. In some sense, I agree. Like, context is what makes your quality goes to the next level. But then when it comes to what context, like what kind of context we want to put, do you want to just put as much as you can? And that obviously comes with its side effect. And that connects to the next one with prompt caching. And this is actually a pretty big one. This is one of the reasons that we did a lot of redesign of our system, because previously we just didn't pay attention to it. And we not following the best practices and have people just inject fields into the prompt as they want. And we just feel like, OK, that breaks the prompt caching, and we just leave the free money on the table. So it's something that, so one rule of thumb here is if you're working on multi-turn agents, you should try to get your prompt caching cache rate to up to 80% or more. But if you constantly see the rate going below 50%, that's something you should take a look. And then there are also eval-driven one, right? Again, the things we did before was the product engineer just receive a bug and did some and come up with some queries, and then they change the prompt. They did what we call the vibe checking, and if things look good, OK, we ship it. That works sometimes, but oftentimes it didn't, because as individual persons change their prompt, no one actually manages and makes sure this prompt still works for all the cases. And so I'm going to briefly touch base on the eval. And when it comes to answer, I think, again, this I'm mostly talking about the LLM and judge eval. A/B testing is a different beast, so I will skip them there. So when it comes to the answer, like things I mentioned before, but what's interesting right now is it's not just answer, it's not just text, right? We're talking about more advanced output, like mini apps or slides, right? The slides, you don't just have content, you have the images, you have the flow. Right? How do you make sure that makes sense? And when it comes to things like browser, you have actions, right? You want to click certain things. You want to type in certain things. You want to book certain things. How do you know it actually works or not? So that's some very interesting ones. And then format and styles, that's another interesting one that people just, some people prefer paragraphs. Some people prefer bullet lists. Some people just want short answers. Some people want long answers. So how do we figure out? And that connects to the personalization. So personalization and eval is definitely another greenfield opportunity. So let me also briefly talk about personalization/memory. So at Perplexity, we really believe personalization is what makes your AI product stand out, because that's what users feel like, oh, this product, this AI actually understands me. They can actually solve my needs. So we think the personalization memory as the first class citizen in an AI agent. And what that means is that we do a lot of work into figuring out what exactly should be stored as memory for users. And that includes short-term and long-term. And that includes how can we do actually real-time update. And this is actually a very interesting one that we build an entire infrastructure just to make sure that if you tell me I like reading books, and you ask me right away what do I like, I will tell you right away you like reading books. And while this sounds simple, again, when it comes to LLM, things are slow, things are brittle, so it actually needs a very sophisticated infrastructure to enable it. And then on the product side, obviously want to manage or have the transparent memory management, as well as privacy and sensitive information. Certain things we don't want to store the memory. OK, so let's also briefly talk about MCP and the tools. So this is, again, a fairly new field, right? MCP is sort of started gaining, I would say, industry traction probably early this year, right? So it's still new, a lot of ideas out there. So I'm going to share what we have been trying. So one thing we found is that instead of having universal tools MCP, meaning you just feed as many MCP to the model as possible, that just doesn't work. You need to figure out what are some high-impact ones. What are the ones that actually make a difference, right? I think probably people say search, right? That's one of them, and maybe coding. So these are some common ones. But what to your product, what actually are needed for, what kind of MCP are needed, and then also make sure reliability. So our experience is that these tools and MCPs are not reliable. Many of them are not reliable because it's so new, right? People are just rush to build them, and then they have a lot of limitations. And how do we actually, internally, I've been also thinking about how do we build an ecosystem, right? As there are more and more MCP out there, how do we actually figure out how to integrate them, how to leverage them, how to figure out that given a particular user request, what are the best MCPs to use. And another interesting one related to MCP and related to model is how do we actually manage the state? So because as the tasks get longer and longer, we wanna, with the browser, we wanna spend minutes and even later, like an hour to help you achieve something. The longer it takes, the more problems you're gonna get, right? The model may be broken, the things can really get worse. So how do we actually make sure that we can recover, backtrack if things don't go our way? Okay, so let me wrap up quickly with some post-training stuff. So I'm going to talk about two items, the system and the reinforcement learning. So the different challenges we've been facing when it comes to post-training, the one of them is just scale, right? As the scale goes by, model gets more powerful, but that comes with all kinds of challenges, especially when it comes to the infrastructure. So we've been spending a lot of time building these internally, we call it Lotus, learning optimization and tuning system. It's all in-house post-training model that support a large scale and can really simple to understand and hack, right? Like researchers come in and like try different configs, different algorithms, different models, and quickly come out with their results. And then we also enable different state-of-art algorithms. So on the side, this is architecture. So happy to discuss that offline. So another quick challenge is, again, when it comes to AI agent, it's not going from the previously chat-based, right, or just question and answer. We want to do two calls. We want to do MCP. We want to do things beyond just text. So that comes with the different challenges. It's very noisy. We don't know when to stop, right? If user asks you ask AI to do things that may take hours, should we actually do it, or should we actually like help user manage their expectation? So we've been training our own model through the reinforcement learning of our own agent and environment. And for example, in this case, we have our browser as the environment that takes the user actions and use that to train our own two-core models. Again, happy to chat more about it offline. Yeah, okay, with that said, that's the end of my talk. Thank you.
Thank you very much, Brett. We are big fans of Perplexity at Intercom. Comment went viral inside Intercom, all showing each other what we did with it. Between Fergal's talk and Brett's talk, I think like preaching to the choir here, but the delta between a vibe-coded demo in a weekend and an at-scale performance system it's orders of magnitude of effort. And there's historically not enough sharing of the knowledge that we're all learning about this. So I love an event like this where we're getting deep into the details and exposing it to people to learn from each other. We're going to take a short break now. Grab a drink, stretch your legs, and we'll come back again in 10 minutes for our last session. Thanks. Okay, welcome back. Thanks, everybody. The technical papers will be open at the end of the event as well. Hope you got to enjoy the break. Hope you're enjoying the event so far. We have 2 sessions left. The first is Molly Mahar from Fin, who's going to talk to us about some of the lessons that we have learned, the hard truths we've learned building AI products. And then we're going to have a panel discussion with amazing leaders from Cognition and Harvey and Fin talking about their own lessons. So please put your hands together and welcome Molly to the stage.
So far tonight, you've been hearing about the technical challenges of building AI. I want to talk from a different angle. I want to talk a bit about the people and the org challenges of building AI products. So as Fergal mentioned, Intercom has been around for a while. So we have habits, right? We have processes. And 2.5 years ago, we had to become an AI company. So we had to redesign, rethink how we design, how we ship, how we organize ourselves, right? So that pain of cultural change that Fergal mentioned is the process of us like doing things poorly, failing, picking ourselves up, and doing it again and again and again, right? Because a company is just a group of people with their own habits, with their own incentives, with their own expectations. And so when you're pivoting into AI, you are asking all of these people to change the way that they work. And I don't know about you all, but like I find it very hard to change other people, right? So these people challenges can sneak up on you if you're not prepared. And so tonight I wanted to share 5 painful truths that I've experienced, at least working on AI products, with the hope that they're at least on your radar if you're building things, might make your lives a little bit easier. So let's get to it. My truth number 1, demos are dangerous. Product orgs love to like share early, share often, but when you're doing AI, like that gets really risky, okay? A shiny demo, it hides brittleness, it hides hallucinations, it hides integration gaps behind it, right? When you're demoing something, you're making a promise about the quality of what you're building. And if you demo too early, you get like product leaders who set like marketing launches and things, right, before anything's done. You get teams aligning around this thing that you haven't even built, right? They're prematurely like rationalizing it into the product. And so we've seen that at Intercom, right? We've seen product teams outside of the AI group, like they have some small little AI feature that's kind of a thin wrapper. So they're like, yeah, this will be easy to build ourselves. They do a happy path demo. People get really excited. They get buy-in. Then they start to build it, right? And it all kind of collapses in on itself as they meet the unhappy path. And they need our help. So here's some ways that we have figured out how to deal with this situation. So we, AI group, we provide like advice and testing resources to other product teams so we can get them set up for success. We keep a lot of projects like secret sometimes. We just keep them on the down low until we're ready. We feel like they're good enough. And when we do finally think that they're good enough to demo more widely, we like hedge those demos, right? Like this doesn't work, this is unstable, like here's where we are, here's how far we have to go, right? So we did that with like the Fin Alpha. We're like working in secret, and then when we finally demo, we're just very clear about what's risky and what's still unknown. So the takeaway there, I think, for you all is demo only what you're willing to be accountable for, and be really clear what's risky and what's unstable. Because as soon as you show something shiny, that polish, it communicates a stability that your product does not have yet. That takes us to truth number 2. Polish is a trap. Do you hear that much from a designer? There's a normal tension in product teams, like do we ship fast, do we ship high quality? But when you're working in AI, you have this new element, which is this thing even feasible to build at all, right? So you've got designers who really want to polish something, you've got product leaders who want like brand consistency. And then you have ML teams who like need to get something into users' hands like fast, right? So balancing that is really hard. Intercom has always had this strong critique and feedback culture. We have the concept of like curious, minor, major feedback that we give. We also disagree and commit a lot. But even those like healthy processes have not stopped us from falling into this like death spiral, I'll call it, of like, you're working on design for something, and your design is like shaping what the output of the model needs to be. And so like if you're revving on design too much, you're slowing down the process of the model, and then you're not actually like able to make it robust, and you can't design in response to that, and it goes around and around and around. You get stuck. And it's super painful and super frustrating. And so how do we try to handle that, right? We've kept the feedback culture, like that part's actually great, the transparency and the clarity that we have between teams. Kind of the new thing we have is my role here, the AI designer role. And I sit between, like we sit between design team and the ML team. And we are like this bridge, right? So we join a project from day one. We are ensuring the system quality from like a UX point of view, and we're balancing that with polish. So we are actually like in the weeds with the scientists. As an example, when we were building the Fin Alpha, I was working on that and felt like there were gaps in the quality of Fin's answers, and we were like really close to going to launch. And I'm like, these are not quite good enough. So so I went in and like started writing my own prompt, like doing prompt engineering, writing my own variations, doing offline evals and testing, and like getting a sense of like, how does this model work and what are the limits to this, right? Coming up with like a good proposal to make to Fergal and to the scientists, and convincing them that like my version is actually better, it's a better experience for the users. And then like handing that off to scientists to make it robust, right? And so that's what ended up launching. So that's kind of how we act as a bridge, and helps keep this like instinct to polish like in check. So the takeaway there, I think, is just resist that urge to polish before feasibility and value are actually proven, right? Because debates about value, polish, they sound like they're about craft, but they're about focus. In AI, like your focus like has to shift overnight sometimes, right? There's a breakthrough, there's a dead end. Suddenly your roadmap is like out the window, right? That's truth number 3. The roadmaps, they will fail you. Any static plans you have are just going to collapse when the models surprise you. Like it just does not work. You have to be reprioritizing all the time. Intercom used to work in these 6-week product cycles. So they had, I saw them, I've like seen these nice schedules that the teams used to have. Each week they knew exactly what they were working on for the next 6 weeks. They had cross-team alignment. That is like no more, right? That's totally gone. Instead, what we do now, we have these like flexible work stream model where like people and tasks like can get reallocated on demand, right? So the shape can always be shifting, and we can be really responsive to the needs of like any project at any time. So we do that. As we're doing weekly planning, we ask, are there any big bets that we're not making that we need to make right now? We also ask, okay, what are the items that we really need to de-risk right now the most this week? So we're kind of like a multi-armed bandit, right? We're exploring big bets that we haven't made, and we're exploiting the things that we know have value that we need to build deeper on. And that rhythm, it feels natural to like ML folks, but it feels like total chaos to product teams who are used to working in these 6-week cycles, right? So there's hidden costs to having to work this way. You have to there's like relationship management, right? Because people are always shifting around. You have to like gain people's trust. You're always renegotiating everything. Like, that's tough, right? That's hard for people to do over and over and over again. But ultimately, survival is about this ruthless, constant reprioritization. So you just have to kind of deal with it. Because customers, execs, other teams, they all want something from you, right? And so that's why no is non-negotiable. No is necessary. That's my 4th truth of the night. Customers are great. I love customers. They have a lot of expectations. They have a lot of requests, right? How do you choose what to build for them? We are lucky. We get a lot of good feedback that's grounded in like real workflows. When we get negative feedback, like this will not work for me, that's great, right? We can really trust that. But when we get like positive, like I think this would be really cool, it's a lot harder to know whether that's a real need that they have or whether they just saw something like shiny on someone else's demo. And so like parsing out like what you should actually work on there can be very, very hard. And it's also very scary It's scary as a person when you're like, no to a customer, right? And they're threatening to churn. Or you say no to your execs who like want something specific. Or you say no to like 5 other teams who want something from you, and you just feel like a dirtbag, kind of, to say no all the time. We just make Fergal say it all the time, so that's like easier for me. But saying no lets you work on the bets that you are making, right? So what do we do to try to like do this well? We use usage data and honest feedback to try to separate out like the shiny stuff from the real stuff. We look really hard at whether something we're thinking about making is a good business decision or if it's just like a really expensive API call in disguise. And like generally our default answer is like no, actually. And it gets easier the more you do it. Because demands will overwhelm you, but like saying no is not failure, it's focus. But one of the hardest things we've like gone through lately is that no only works if people have authority to make it stick, right? So the last truth is ownership can sink you. Like products live and die by like who's the DRI, right? The directly responsible individual. If you have the wrong owner at the wrong time, like you can totally sink your product because people have like their own agendas, right? So Intercom used to, like the ownership model we had before was this triad model with like a PM, a designer, and an engineering manager, and they made decisions like collaboratively. And that's great for like working together and like having a lot of agreement, but it's a lot slower. It dilutes the decision speed. So we've tried new things and new models as we are like working on AI products. So we tried just like PM-led teams, but 2 things we've noticed. Marketing pressure tends to like creep in there and like push to like launch too early. And then it can be hard sometimes to say no to like a lot of customer demands from some like big customer, right, that you might be trying to like build for. We've also tried ML-led teams. And it can be hard, like you build it, it's great quality, but like then you have to hand off to a product team to like own it. And they might feel a lack of ownership, right, or a lack of vision in like what you've built, and so you might not get enough like investment afterwards. So what we do now, we have this like PM as the DRI, and then strong like a technical ML lead and design lead who are like advocating for those for our positions. But like the PM is kind of, you have a single decision maker, right? So you can move faster. And we found that to be like pretty smooth. It's not perfect. We're like still working things out. Like one of the tough things is that doesn't necessarily work the same way for every project because you've got different people, right? And people are not interchangeable totally like on different projects. So things work differently. But the takeaway I think is you have to scope decision rights as carefully as you're scoping your features when you're trying to build these. Because if your ownership fails, like all those no's you said they mean nothing, like your roadmap still collapses, polish doesn't matter, and your demos, like they were all false promises because like your AI product is just like off track, right? So I think competing in AI means you have to live these truths like every week. So you can't just ask like, is our model ready? You have to ask like, is our company ready to handle all this pressure? Am I ready to like hold the line in a tough situation? I think, yeah, like one half of like survival is like, do you have a really great model? Do you have really great tech? But like the other half is like, do you have a bunch of people who are willing to like deal with really uncomfortable situations and like hard stuff and like maybe go cry in the bathroom and then come out and like work together and like leave at the end of the day with like a smile on their face, happy to come back the next day. Because I think you need both of those parts to be able to really be successful at building AI products. Thank you. That's it.
Thank you so much, Molly. Truly hard-fought lessons the last couple of years as we've transformed Intercom from this historical SaaS company to an AI-first company. It has been blood, sweat, and tears, and everything we thought we could take for granted has changed. It's been really, really fun. Okay, Our last session then, we're going to do a panel with amazing leaders from these companies. We have Nico Gruppen from Harvey, the AI for law firms and the Fortune 500. We have Silas Alberti from Cognition, the team behind Devon and Windsurf, and a person called Fergal Reid behind a product called Fin, you might have heard of. Please welcome them all to the stage. Okay, thank you very much for doing this, folks. If our thesis tonight is, it turns out that building great AI products is more than just a thin wrap around an LLM, to say the least, and that there's durable advantage in that. My softball is like, do you agree? And what does that mean for you? Maybe start with you, Nico.
Yeah, we can go in a number of different directions with this one. So first of all, I think the way that you frame the question absolutely aligns with my mental model, which is the product as the focal point. I think our story, though, actually starts even one step earlier than that, which is by partnering with our customers, in this case, law firms, embedding ourselves or immersing ourselves in their workflows and understanding their core problems. Right? So something we take a lot of inspiration from at Harvey is unreasonable hospitality. So this is, of course, a reference to Will Guidara, his book, 11 Madison Park, the restaurant in New York, and the operation that they've been able to spin up quite successfully there, in large part due to their unique approach to services-based work, right? And so what this means, from a product development standpoint, what we're trying to convey by taking that as inspiration is it actually starts with deep customer obsession. What are your users and what are their core problems? Only after you understand that can you work your way backwards to the product and product experience that's needed to solve those problems. And then you work your way backwards to the AI models and systems that are needed to support that product experience. In my experience, it's really challenging to try to push AI functionality in the other direction. Given how quickly the ecosystem is moving, there's a lot of incentives and external pressures to do that. And then when it comes to actually building a product, I get asked this question all the time, which is what's challenging about building at the application layer. I think the reality is, and I really don't think that enough people talk about this, is that it's all challenging, right? There's quite literally no easy part, right? There are certainly frameworks you can use to kind of scope or frame the difficulty of a problem. In the AI world, the things I'm thinking of are things like, how much domain expertise is required to solve the problem, how verifiable are your outcomes, how much does the problem space rely on manual processes or tribal knowledge, right? And that helps you frame the AI problem, but it's just one in a basket of other problems, including infrastructure, integrations, security and privacy are table stakes for enterprise use cases, and of course, intuitive UX and design. So the main takeaway for me is when you sign up to build at the application layer, you're signing up to solve this whole problem, right? And you have to master each of the individual components to deliver a valuable product to your customers. And
it feels fractal, right? It feels like going from it's like getting 5 nines reliability or something, right? It's like the deeper you go into it, the harder and harder it gets. You started with the idea of it sounded like I interpret it as domain expertise. You really need before you even get to the AI, you need to deeply understand what problem you're trying to solve. Silas, I think I've heard something similar from Devon, something that's very compelling about the way I've heard Devon being framed is it's not a coding agent, it's trying to solve the job of software engineering. Is that, do I have that right?
That's correct, yeah. Yeah, I think I also very much agree with the overall thesis here. I feel like 2 years ago, everybody was talking about these oh yeah, the labs are going to eat everything, there's these thin wrappers around it. And I think we started out being this applied AI lab and also not really sure initially what is going to be the bulk of the stack that we're going to own. And then we started actually talking to customers and building stuff for them and noticed the problem of actually delivering value to real engineering organizations is actually a very deep product problem. So it started with all the infrastructure on actually enabling software engineering agents to work in real enterprise environments, from virtual machines to run the code, and all the plumbing to connect them to your AWS and your Jira and your Linear and your GitHub. And also all the different interfaces that you want to build, whether it's a web app, integrating with Slack, and even now the IDE with Windsurf. And I think the other deep product problem that we think a lot about is interfaces. So on the one hand, obviously, the IDE is a pretty big interface for software engineering, but also we all kind of believe, okay, that might not be the interface in 5 years. But we also don't think it's just going to be a chat. I think a lot of what we think about is what is the real future interface of how people write code. And we think it's a pretty challenging design problem that also involves co-designing ML systems and even models. And I think it hasn't been solved yet.
No, yeah, definitely hasn't. The idea of, we'll get into the model stuff, certainly. The idea of interacting, there's something in my mind about, if you're trying to solve, I'd love to understand the equivalent in the law use case. But we think about this a lot with Fin, is if you're trying to solve for us the job of replacing what a customer service rep does, it isn't just answering questions, they have to interact with the rest of the team. And Devin, Silas, the services, how it interacts with the ecosystem it's in. What kind of interaction patterns and surfaces are you imagining might be in the design envelope there?
A lot of things. I mean, it starts with the source of the task, right? So the task might come from right in the developer seat in the IDE, but it could also come from some customer bug report in Slack, and then somebody tags Devin right in the thread there. It could also come from some issue tracking system like Linear, and we even imagine a lot of other sources of tasks that are already possible with MCP integrations like Datadog alerts triggering automatic agent triage.
Or Fin. I'm looking forward to the day where Fin opens a task for Devin in Linear and then gives Devin a hard time. Hey, it's been 2 weeks and the customer's asking for an update. What's going on, Devin?
I'd love that.
That's going to happen, right?
That would be sick, yeah. I think, right from customer bug report in Fin to PR.
Yeah, absolutely. The law use case, what is the shape of the interfaces you might have in Harvey?
Yeah, well, first of all, I think Silas's point on interfaces is spot on. In fact, we call the discipline applied research at Harvey very intentionally, right? And what that's intended to convey is that our responsibility here is actually equal parts AI and HCI. And what I'm referring to is human-computer interaction. On the HCI side, it's all about what is the right mode of interaction with the models and with these AI systems, not just generally, but for our specific users who are legal professional service practitioners. The biggest sort of transition we've seen here is there are some extremely complex tasks that these folks are taking on a day-to-day, week-to-week basis. So if you imagine something like fund formation, right? If you're a private equity firm, you're raising a new fund, this is something that will take multiple weeks, potentially multiple months. There are negotiations between a number of parties, correspondence between lawyers and clients, with LPs to negotiate specific terms and carve-outs and side letter agreements. Incredibly complex process, right? It's not clear, and in fact, I'd go so far as to say, it's not going to cut it to have a light kind of multi-turn interaction or a chat interface with that, right? Really what our users are craving, and the direction we're starting to steer our product, is towards a persistent workspace that houses all of the data and information and work product that you need, right? So if you're going to raise a new fund, you can show up to this workspace. It has all of your historical precedent from deals you've done in the past, intermediate work product that's completed by the legal team as you go, all of the correspondence, email threads, back and forth, attachments with legal counsel and clients, and then eventually kind of the finalized, kind of polished work product that you end up using to sign and close the deal. So all of this is self-contained in one workspace. And then as the process kind of unfolds in these phases, you can delegate tasks to agents to complete along the way. You can delegate tasks to humans along the way to complete. You can delegate tasks to human agent teams to complete along the way. And we're already getting asked for this to be collaborative and shared between law firms and their clients. So we see a transition from these lightweight, almost like ephemeral kind of interactions to something that's persistent, has memory, and is self-contained.
What I was going to prime you on for was this is the amount of depth required in really not just executing a task, but solving a job end to end is what I'm the thing that is occurring me in both of these cases.
Yeah, I just think it's fascinating to listen to this, and just because there's all this narrative around AI is getting more and more general, and will it solve all these problems really, really quickly? Is it going to be 6 months and it's going to be doing everything? And there's just so much complexity to any given task. I mean, we see that in customer service. We often think about like, customer service can sometimes be like the exception handler or the system integrator of last resort, right? It's the thing you go to when you need a human to navigate your org and make something happen, and like the system couldn't do it automatically. And so like you bump into the same thing, which is there's just an insane amount of complexity to actually doing real tasks, outside a lab or a back test, but actually in a real messy environment. And it's fascinating to hear that across the different disciplines, across the different domains.
The messiness of all the different interactions, the idea of escalating to another AI agent or escalating a problem to a human, getting a human to go do something for you. It's like there's a lot of domain complexity there. But even something that's interesting is like even if it's just executing a task that requires looking up data and integrating with an API, getting a complex process to execute reliably is exceptionally hard, it seems. Like any lessons, maybe Fergal, starting with like things we've learned from that idea of the compounding error, like low error rates for a complex task is a hard problem.
Yeah, we've learned it's really, really hard. I'd say that's, so like we have this tasks product where you'll go and try and do something like issue a refund or something like that. And it's very easy to get a demo that like works right now and again, but it's very difficult if you have like 6 different steps that need to be completed reliably to not have like an error creep in. And so our approach at the moment where technology is to try and build like a tool set to help our customers factor that big complex workflow they're trying to do into like subcomponents that an LLM can reliably execute on. That's the direction we're going. But yeah, it's really hard to know. Like this is definitely the frontier, and I think it's very easy to make a demo, but it's an awful lot of work to actually complete this long, multi-step running process in a messy, unconstrained world. I think that's still very frontier and maybe some distance away from, certainly from LLMs doing it out of the box. I think you're going to need product, scaffolding and building blocks and everything around that for a long time.
Yep.
That's at least our thesis.
Yeah, no, I mean, I totally agree. We have basically the exact equivalent of that problem. Obviously, a common legal task is large-scale kind of document review. So we have a product called Vault that's intended to handle these sort of use cases. Lawyers can upload 100,000 files at a time. We're in the process of increasing that to 1 million files at a time. And for those of you who have interacted with lawyers, they're not your typical document, right? So an actually really common use case we have for our Vault product is to upload and analyze and extract key terms from credit agreements and loan agreements. If anyone here has worked with a loan agreement, a single one of these things can be 400,000 tokens in length, right? Which is, for those who are wondering, longer than the Dune novel, which is enough content for 2 movies, right? 2 of these things is the Lord of the Rings trilogy, right? And lawyers don't just have 1 or 2 of these lying around, right? There's thousands of these lying around, so you need to be able to handle that process. And so I've said from day one, AI is kind of the star of the show right now. The real heroes of the application layer are those who are sorting out AI infrastructure, because it's all novel infrastructure as well. And then one thing I want to hit on, which I think you hit on, which is really unique, especially as agents are taking center stage right now. What we're seeing is infrastructure for long-running asynchronous agents to complete increasingly sophisticated tasks. That is one mode of completing complex work, but you're not guaranteed to have the same input every time, or the same output every time, right? There's some variance, there's some stochasticity baked in. So what we're seeing is you need a complementary product that can handle repeatable, deterministic units of work, right? So you can identify the agent trajectories that go well and then map them to building blocks that users can interact with and execute over and over and over again.
Yeah, that's something we find is like, to do these things well, you need to be able to mix generative stochastic processes with deterministic, reliable things, and like the blend of that is interesting. Yep. Okay, so essential domain complexity, you need to understand the domain. Really hard to, like, once you're in that domain and interacting with the rest of the world, getting it to actually do things reliably is really hard. One of the things we're talking about today, announcing today, is that we're tuning our own models. Like, that's the next bit. Even if you do that all perfectly, there is leverage durable value in tuning your own models for parts of the system. Silas, I think that's something that the Cognition has done a lot of. Like that's part of like was that part of the appeal of acquiring Windsurf? Like,
yeah. So we think about training models in a certain way. So first of all, I do think there's this interesting new development of application layer companies getting into model training, as Fin is as well. I do think the philosophy is a little bit different. I think at a large foundation model lab like OpenAI or Anthropic, there's these like separate research orgs that do long-term research and sometimes quite far away from product. I think for us, the product has always been the primary goal. So we try to kind of like go backwards from the product and figure out where does it make sense, where would actually a custom model lift some like user metrics or enable like a new experience. And there's quite a few places across the stack where we found this to be the case. So, and it is true that in Windsurf, there had been quite a few of these. For example, most famously, the tab model, right? We all know Copilot back in the day pioneered this, but actually Windsurf, before it was Windsurf, was called Codium and had one of the early products in that segment as well, which later evolved to be like doing multi-line edits and tap to jump. So that's continues to be a big focus for us. But we also have SWE1, which is basically our like frontier coding agent model that was released in May and is still one of our most popular models and basically powered by like reinforcement learning and software engineering tasks. And this is, for us, just the beginning. There's a lot more to come on that front. Besides that, we also see a lot of potential for training specialized models, both for certain verticals. We've released, for example, the Kevin model. It's a little of a open source research project. We wrote a blog post and a paper about it where we trained a model on a specific coding vertical, which in this case was CUDA kernel writing. But there are many more of these verticals that we work on with our enterprise customers. And then the other specialization that we see is around speed. So very often, coding agents take minutes or even tens of minutes. And sometimes this is fine if you just are like in the purely like delegation mode and you maybe come back half an hour later in the review. But very often also there is this desire to be in the loop and actually drive the iteration of the agent. And for these cases, we find that the difference between waiting like 45 seconds or 10 seconds can be the difference between switching to another tab and scrolling Twitter or actually waiting for the agent to be done.
So these are the trade-offs Brett was talking about, like the different dimensions. Like the one for us is the latency budget we have on voice is wildly different than the latency budget we have on email. And we can do very different things in terms of accuracy and cost trade-offs there. And it's a really hard problem. And like, yeah, the fine-tune things, like one of the things I personally get most excited about and the stuff that Fergal was presenting was the latency improvements and our ability to, when we have the model, we can control the latency a lot more directly as well. Is Harvey also like bought into this idea of like, hey, tuning models there's leverage?
Yeah, so we've been doing this since I joined 2.5 years ago when the company was 6 months old. I think you bring up a good point, actually, which is RFT is super popular right now, but distillation is still a very viable option for taking the reasoning capabilities of larger models, distilling them into smaller models that can do the same task, but much cheaper and much faster. Yeah, we've certainly had our own model training journey here. Actually, when I joined, the sort of state-of-the-art approach for customizing models at the time was continued pre-training or mid-training. So what we did is we literally took all of US case law, which is about somewhere between 10 and 12 billion tokens, and we literally did next token prediction over that in the hopes that we would find sort of step change legal reasoning capabilities emerge in the same way that these other reasoning capabilities emerge from the models. Long story short, it worked in part. I don't think it was enough to move the needle, right? This was at the same time that RLHF kind of came around. You can gather, really the thing that we want to optimize for at the end of the day is lawyer preference of outputs, right? And specifically partner preference of outputs. If you can gather a few thousand examples, you can, train a reward model, do DPO, or do DPO directly on the preference judgments. and you're off and running. I think today we're much more focused on RFT. I think one thing we're really interested in is if you imagine this sort of emerging AI native stack of models where you're doing inference, model systems, and tools, and then agents that operate on top of them, an area of investment for us is actually beginning to simulate some of these legal tasks end to end, right? So imagine the fund formation process that I described above. If you can simulate this in a sandboxed environment, you can actually begin to train agents to complete subtasks or the entire process end to end. The bottleneck there has and continues to be strong verifier models.
I have to wrap us up now, Billy.
Nick, I'm just really curious there. The simulation, is that like using an LLM as a simulator, or is it more like a reinforcement-style playground sort of simulator?
Yeah, so what we're sort of envisioning is, I described the workspace concept just a few moments ago. You can allow an agent to take actions within that workspace, including actions, the choice to interact with other humans via email, right? Cool. So we have tools essentially for research, tools for drafting, and tools for human interaction. That is essentially an action space for an RL agent. The application in this workspace is the environment. And we're looking at ways that we can scale up the simulation to make it work in practice. I would say it's still, forward-looking, but it's something we're investing a lot in.
It's so exciting. I remember learning about reinforcement learning, way back when, I had a reinforcement learning startup in 2014 or something like that, and back then it was like multi-arm banded for website optimization. Now it's like an entire line of business tasks could be in the environment, or software engineers in the environment. It's just wild. It's exciting.
The thing, I'm going to wrap us up now, the thing that I keep coming back to is the Alan Kay quote. I'm just thinking about the depth at all the layers of this conversation, from the application layer, the AI layer, and then now into the model layer. Being able to have the expertise and the ability to own all of that unlocks these huge capabilities in the products that we're all building. Okay, please put your hands together for a great panel. Thank you guys. Thanks, and thank you very much for coming this evening in general. Please give another round of applause for all of our great speakers, Brett, Molly, Fergal, Silas, and Nico. And thank all of you online and here in person for joining us and giving us the time. It was really great. If you're interested in learning more about the technical work we've been doing today, Fin.ai/research online. And in person here, we have technical paper sessions where you can talk to the scientists and engineers who worked on this stuff. And maybe one favor is if you can go back and talk to your customer leaders about using Fin, that would be really nice. Please hang around, have a drink. It would be great to talk to you all. Thank you very much.